Hello, everyone. Today, we are going to be looking at the correlation concept. We have a task. We are given data on IELTS scores, and we need to perform the correlation exercise. So first, we need to calculate the correlation coefficient of the two data sets, that's for writing and for reading. And then we need to comment on the strength of the correlation between the two data sets. So first, we need to understand what correlation is because we are newbies. Correlation is a standardized measure of the relationship between two variables. So we want to know how much these two variables are related. Correlation has a measure and is a standard measurement that ranges between -1 and 1. So if we have a positive number, it means we tend to have a positive linear relationship. If we have a negative number and it's -1, it's lower than -1 or it's from -1 below, then we tend to have a negative linear relationship. So what that simply means is why one of the data it's probably going up. In this case, we are talking about IELTS scores. So what that could simply mean is if the writing score is, if the scores for writing ranges high, then maybe the scores for reading is ranging very low. That's for a negative linear relationship. For a positive linear relationship, it simply means that the writing and the reading score are either going high or going low together. Students are scoring high in writing and also scoring high in reading together. If your correlation measure is 0, it means there's no linear relationship between the two values. Have you ever had a statement where people tell you, if you are able to score well in writing, then there is a high likelihood that you will score well in reading? That is what we are trying to practicalize today. Using a 5-man sample of their writing score and the reading score, we want to know if in IELTS, if we can score well in writing, we can most likely score well in reading. So to begin to calculate, first, we will need to solve for covariance. What is covariance? Covariance is the measure, helps us to measure the degree to which two variables changes together. While the writing score is changing, the reading score is also changing. For person 1, we are seeing that this person scored 344 and for his or her reading scored 378. But person 2 had 383, which is a high score, but had 349 in reading. So first off, the scores are high. And whenever you score high in writing, you most likely will score high in reading or almost high in reading. So that's what we are trying to measure. Let's get right into it. To perform this action, we need to work with this deviation formula first. We need to find the deviation for person 1 and 2, person all the way to person 5, and then calculate the sum of deviation. Identify what our sample size is, and then find our covariance sample, and then perform our correlation coefficient. So I would be taking out all of these values here so that we'll be able to run our calculations individually. First, let's look for the deviation for person 1. We already have this formula. We need to follow it. The formula simply means X representing writing, Y representing reading. The writing score minus the mean of writing times the reading score minus the mean of reading. So let's do that quickly. Equal to, open bracket, writing minus the mean of writing. We already know how to find mean already, so I believe we'll do that when given this. Multiplied by the writing, our open bracket, reading minus the mean for reading. Close the bracket and enter. And I have a value. So I'll quickly do that for every of the persons we have here. All right, so we've successfully calculated our deviation for all of our samples. The next thing we need to do is calculate the sum of all of our deviations. To do that, you simply use the sum function right here to highlight all of these values, and then you get your value. All right. Okay. And then we also need to identify our sample size. By using the count function, I simply counted all of our inputs in writing. So you can choose to count all of the writing or all of the reading. In this data set, we have equal number of writing and reading. So choose any of the columns to count, and then it would return the fact that we have a 5-man sample here with us. And now we need to calculate our covariance sample. Okay, so to do that, we would need to calculate our sum divided by our sample minus 1 to eliminate any form of error while calculating. And then we click on enter, and then we have this value as our covariance. Following our covariance measure, we can simply see that we have a positive covariance. Our number is positive, and it simply indicates that our two variables are moving in the same direction. Whenever anybody pass writing, they would pass reading, and whenever anybody pass reading, they would pass. Whenever anybody pass reading, they would pass writing. All right. So there is a strong covariance relationship between these two data sets, between writing and reading, using this 5-man sample. Now let's go ahead to calculate the correlation between the two. We'll be using the correlation function to perform this. We'll click on equal to correl. We'll be highlighting all of our values in writing, comma, all of our values in reading, and then click on enter. And then we have 0.94. Our task asked us to comment on the strength of the correlation between the two data sets, that's for writing and reading. So 0.94 is extremely close to 1. Therefore, there is a very strong positive correlation between the two data sets. First, we have a positive number. Secondly, it's very close to 1. So it's a very strong correlation between the two data sets. Usually, in the calculation of covariances or correlation is preferably used because first, it's straight to the point in calculation. Second off, it's less complicated. So if you want to calculate the relationship between one data set and the other, we can always use either the covariance method or the correlation method, or better still, use the both to seal your arguments. Thank you. See you in the next class.